Welcome back to the Benjy podcast. This is episode 4. This is a very different episode because Benjy is now with a mustache.
Yes, indeed. I have a mustache now. Yes. You can't see it. You'll just have to believe us. I grew it for Purim. It's Jewish Halloween, basically, for those unfamiliar. I've noticed people they address me a little differently with the mustache.
How so?
Well, I think I'm more trusting for some reason.
You're more trusting or they're more trusting?
They see me as more trusting.
Okay.
They're more trusting of me. Yeah. At least I think so. And I feel like they listen to me more. Whereas with a beard, I don't know. I think I was more intimidating, and which is weird because usually when you have a beard, it seems like you have a lot of wisdom to share. And I'm hoping that doesn't affect the podcast also.
Right. I hear.
I think I might not have as much wisdom now.
Well, this is a bit disappointing for the mustache itself because it's not the mustache that is giving you any advantage. It's just the reduced facial hair.
Exactly. Because the mustache was there when I had the beard.
Right.
It's just now been brought out due to lack of beard. So what is a mustache? It's just the beard minus the intimidation and wisdom.
Nice. Just the teddy bear affectionate look.
Exactly.
You're
like, there's a little bit of, did he mean to leave that much? Did his shaver run out of battery halfway?
Wow. Okay. So with that intro, we are going to be discussing a few related things. We're going to be discussing consciousness, what is consciousness, and if it even is a real thing. Because what if a robot were to be so sophisticated that it would look like a human, act like a human, and to the point where another human being wouldn't even be able to know the difference, and wouldn't even be able to know that the robot was not a human being. At that point, is there a difference between this robot and a human being? And then also, there is the classic Turing test, which Alan Turing, I think he came up with it. Benji, you can tell us more about the Turing test.
Right. Turing did come up with the Turing test specifically. It's probably philosophized about before, but he lived at a time where computers were really in their infancy, were just theoretical models that he dealt with a lot. Just before they had any capabilities of doing what they're able to do today, they could only add up a few numbers. He was already thinking about 50 years ahead of time when computers would actually be able to simulate a human.
The Turing machine is a theoretical, didn't actually exist at the time, but it was a theoretical machine that could do any theoretically computationally possible operation.
And he was already thinking, what cannot be computed with a computer. Meanwhile, the computers they had could only do very basic arithmetic, and he was already, thinking all the way down the line. So he was ahead of its time. He also did the Enigma machine that cracked the Germans' codes and stuff. But that's irrelevant to our current conversation, which is the Turing test, where he was really interested in, what it means for a computer to be intelligent. And a computer really, at the end of the day, is just it's a pre-programmed machine that does a whole bunch of calculations or computations to basically simulate something that you want to be simulated. And it does so on a digital plane, I guess.
What does that mean? What's a digital plane?
Well, using electronic signals to do its computation. Theoretically, it could be anything, but electronic signals are just super fast. You could use, what do they call those boards with the beads to add up?
Abacus.
An abacus. You could have an abacus is technically computational. If you have a analog clock that computes, that's technically a computer, but it's analog, it's not digital. So
okay.
So the medium of which a computer computes is also not so important. Technically, you can make a computer as fast and capable out of gears as the ones we have today. So it's more just the theory of what is computation, which is at the end of the day can be reduced to a bunch of and or not gates, where it's just Boolean logic of ones and zeros. If you have two ones and you do an and operation, you get a one. And so everything your computer does at the end of the day can be reduced to just those simple operations, and everything um, that we see that when we really interact with the computer is just layers of abstraction on top of one another. And the idea of a human brain is also is also a computational model, slightly different medium, but you have neurons at the very base, and you look at those neurons and you don't really, you can't really see what's going on, but there are these layers of abstraction built one on top of the other that really what the behavior of a human or any animal at the end of the day is just a much more abstract version of what's going on within the cells, at least according to most people.
Wow.
Well,
Okay. I
that was a bit of an assertion.
don't know about most people.
This, at least according to my beliefs and other people,
So here,
and Cal might disagree.
so can you repeat that position? Because I think that's going to be an important thing we're going to come back to as a point of contention. What was that exact position that you say at least you believe in? Many other people.
Well, it was a claim that the human brain is a type of computer. In the same way that a clock or a computer is, it just has a different medium. Sorry, a digital computer or calculator. It just has a different medium to which to calculate the very basic operations
Mm-hmm.
to which, and in order to like process those operations. And then you have all this complexity that basically arises because of these very simple operations. And we could see the same thing, when you're watching a video on YouTube that really comes about, because you have, it's really just a matter of pictures flashing one right after another, and to draw a picture on the screen, it's composed of three red, green, blue values, and each of those are stored in an integer Boolean fashion of just ones and zeros every number, and data structures. But when you're watching the YouTube video, you don't see that at all. But
Mm-hmm.
this complexity arises, and my assertion would be that that's basically all there is to it. You have all this complex human behavior, but at the end of the day, it's just a bunch of neurons firing in the brain,
Mm-hmm.
which, if we look at what a neuron is, you have this action potential that grows based off of these chemicals that are emitted from the previous neuron. It's kind of like a recursive operation where one neuron, or maybe it's like a tree, one neuron's activation leads to the next one, and then once it passes a certain threshold, like it sends a charge, it like achieves a positive negative charge that then propagates along the myelin sheath, or the axon of the neuron, all the way to the end, and that releases neurotransmitters at the end, and these can be inhibited when you drink alcohol or any other drugs have an effect, and then it's just basically neurotransmitters shooting in between neurons, and then you have some localization within the brain, and with different regions of the brain responsible for different things, but they're all interacting with one another. And at the end of the day, you have a human who has hopes and dreams and relationships and hobbies, but all of those are just, at the end of the day, neurons fired. But this is, Cal might have some things to say about that. But to get back to what the Turing test is, it really is just you, in order to determine whether something has intelligence, the basic assumption is that there's nothing, in the basic assumption that Turing makes is that there's nothing that you could really point that says it does or doesn't have. I mean, it's probably, you could probably disqualify a lot for being not intelligent, but it's hard to like say whether something does qualify as intelligent. And he argues that all we have is you compare it to something that we assume is intelligent, like a human, and you place the human behind the door, the computer behind the door, feed them the same or similar answers, interact with them, have a conversation, and if the computer performs indistinct from the human, meaning you have the human guess which one is the robot, which one's the computer. If they if there's like a random or like 50-50 result, that means that the human in the testing the computer can't distinguish between them consistently, and so thinks that they're intelligent. And this method has a lot of obvious problems with it. That it could be that you have a computer that is intelligent but won't pass the test, and you could have a computer that will pass the test but is definitely not intelligent. And what does that mean?
Mm-hmm.
Um, so you could have like an intelligent computer that, if you ask it to factor a large number, something that a regular human wouldn't be able to do,
Right.
he wouldn't pass the test because the tester would just see, wait a second, someone can't solve that quickly. It
Right.
must be a computer.
In fact, he's too intelligent. He's so
Too
intelligent that he
intelligent.
doesn't pass the test.
Exactly. And there are also like just other things that an intelligent computer has the potential to have, but like have access to, but just doesn't know about because they're inherently human issues, human, like just related to being human. And then you could have machines that will pass the test, but are definitely not intelligent. If you just had a giant dictionary that just contained the solution to every possible question asked, it just memorized everything.
Mm-hmm.
Um, well, that's just a book. It's not an intelligent computer.
Mm-hmm.
I mean, it's just a big lookup table. And we assume that intelligence is more than that. And you could just have a computer pretending to be like a person, but a silly person or someone who doesn't understand the language as much. And that's basically the gist of the Turing test. So,
Okay. Okay.
and I don't know, maybe do you have any other ideas of how you would determine whether something is intelligent or not?
So honestly, to answer your question, we have to back up
Mhm.
because we have to talk about what we mean by intelligence. Um, and of course, Alan Turing was trying to tackle that very question, and he, exactly as you said, he kind of said, "Well, there isn't really a great answer, but here is something that maybe is something that points to whether something's intelligent." The Turing test, putting a computer behind a door and a human behind a door, and the human being able to tell whether he's talking to a human or a computer. Um, Now, I think that uh, if we look at so the word intelligent, at least before we got into the world of computers, we it would be a word that we would apply to other human beings. Maybe it could also apply to animals as well. But the point is, you're applying it to kind of organisms like us, and there's something going on there. I think when you say that somebody like Stephen Hawking or Albert Einstein were intelligent, and that's meaning it's we know what we're saying, but we're also applying it specifically to a human being in a way that's saying in a way that there's an implicit statement there that it is at an impressive level for a human being.
Mhm.
Um,
So you're making the distinction between classical use of the word intelligence, which is to make set aside like a subset of a population or something, like to distinguish them, that they're more intelligent than than another. But you're saying what we're talking about is an intrinsic characteristic, a quality that either creature or an organism or a computer has or it doesn't. So not the extent of to which it's able to solve complicated problems, how fast. That might be the classical intelligence, like whether you're able to recollect things, memorize things, figure out solutions to problems. You're
okay.
saying it's not necessarily that, it's a quality that something has. that sets it apart from just being a rock or an inanimate?
Well, no, I wasn't saying that because that's what I would say is consciousness, and I think consciousness, when it comes to differentiating between the human being and the computer, is a more helpful term. When it comes to intelligence, there's an adjective that were ascribing to other human beings, and we could extrapolate it to animals because we could imagine an animal being as intelligent as a human. And so, like all the things you said, right? Ability to recollect information, ability to make deductions, ability to do mental math, things like that. Um, and so, there's all these mental skills that us humans have, and some people were better at them, some people were not as good at them. And especially those of them that were helpful, that allowed you to be more productive and more useful to other people, allowed you to do something meaningful in the world. Those we tend to think of as, oh, those are intelligent mental patterns, as opposed to someone who's just loafing on the couch all day and not able to tell anyone anything that interests them. That doesn't seem very intelligent. It's not very helpful. Now you could have a machine that does very helpful things, right? That you could have a machine that does math faster than a human being. You could have a machine that you know retains far more information than a human being. You could even have a machine that makes analytical decisions, analyzes data, makes conclusions, all these things that we would attribute to an intelligent mind. And the reason why I hesitate to say that any of that is intelligence is because it's it's doing the end effect of intelligence, but without what I view as the thing that is required for us to really say that it's intelligent. I'm trying to determine exactly why it just feels like a word that has to be applied to a human being. I'm trying to think of another example. I was trying to think of like somebody who's good at basketball. Would we say that a robot who's good at basketball? Would we say, oh, you're really good at basketball? Yeah, I guess we would say that. I mean, we wouldn't think it's impressive. We wouldn't think like, oh, you practice a lot. We'd be like, okay, you're programmed to be super good at basketball. Um,
Okay, so we're leaving aside the idea of consciousness for now, for a second.
yeah.
First, we're focusing on whether a computer is capable of being intelligent.
Hmm.
And I think that would be something that I would agree with you on, it being a difficult thing to tell. Um, because the way that like an intelligent program works that we might see as intelligent um, can I think be based I would break it into two examples. I guess at first there's in today's technology we have LLMs, large language models,
Hmm.
and we have deep reinforcement learning.
Okay.
And these are two ways of creating the most intelligent machines that we have to date. They're also expert systems, but expert systems are definitely just pre-programmed. Like it's very clear. An expert system, you just give it the assumptions, and it uses the laws of deduction, of logic, to come to some conclusion. Um, and whatever it has in its knowledge base, that's what it uses, which can apply to everything. But it's a lot clearer. It's a lot simpler, and it doesn't reflect how the human intelligence or the human brain works.
Pardon me. What was it in the last few sentences? In the last few sentences?
The expert models, the expert systems.
Okay.
That's where it's just pre-programmed. So basic AI for the longest time before the invention of neural networks was just the best we could do was expert systems where you just had very smart people, experts,
Hmm.
coding, giving the laws of and the fundamental knowledge in,
Yeah.
and then using basic, whether it's a decision tree, which it just decides to take one path based off of the previous state, or it's just deduction, where you just have if all sheep are white, there's a white sheep, that sheep must be white.
Hmm.
But then came in the early 2010s or the 2000 teens, I don't know how we say it nowadays.
Okay.
Then came deep reinforcement learning, and that's where you allow an agent to interact with the environment, and you give it a reward, and you don't give it any. inherent domain knowledge. You just let it interact. All you say is, here's the reward, update your update what you think is the right action to do to get this reward. And I'll take a step back because before that, they invented neural networks, which are just big models. The simplest way to think about it is that it's just a lot of random numbers that are just being multiplied by one another and added. And at the end, you get some output that's either a one or a zero or a continuous number, but it's just you apply some function that squishes it to that restricts it to some domain that you want to be between the output should be between 0 and 1 or whatever.
Mhm.
And that was the first time that and the way it's trained is you basically allow it to guess and you keep saying no, that's wrong. You give it an error, it has an error function, how far away it was from the error, and then you allow it to back propagate this error, and it updates its weights that are initialized randomly at first, and slowly but surely it converges on some solution. But we have no idea what these numbers are, how it arrived to these numbers, or what it's doing behind the scenes, because it's just a million numbers doing whatever they want uh, in order to just minimize this error function that we've defined.
Okay.
So that was the first step in making something that's not an expert system. It's learned something that hasn't been pre-programmed.
Okay.
Then deep reinforcement learning came along and took that to another level where it allows it to interact, so regular neural networks basically just did classification with whether something's a cat or a dog, uh, or regression, which outputs a continuous number, like how much a house should cost. Deep reinforcement learning came and said, these are the actions you can take in an environment, and now it could play games.
Mm-hmm.
It could figure out how to beat the best chess players. Well, I mean, they already had that with more of an expert system, but it figured out how to beat the best Go players. They weren't able to create such a system for that, and that also mimicked the human brain a bit more. So the neural networks mimic the human brain because there's so many neurons just shooting neurotransmitters in between each other, and we don't know what's really going on underneath it all. Deep reinforcement learning added this reward function, which just as humans have all these hormones that are emitted whenever something pleasurable is done or painful is done,
Mm-hmm.
it updates our behavior accordingly. And then came LLMs with ChatGPT, which used a mixture of deep reinforcement learning, but at the base of it was this transformer model that is basically a neural network, but it understands better the relationship between words and what to expect when given a word. But its intelligence can basically be summed up as being really good at predicting the next word to output, the next thing to say, the next. So, so that also reflects humans a bit because um, we're very good at anticipating the next thing. That's kind of also a lot of human behavior, whether it's music uh, and being able to just anticipate the next note that should come. And if a wrong note is played, then we know that that's discordant or unexpected. When basically teaching kids, in school, they always say the kids learn a lot to just predict what to say when given um, a prompt.
Mm-hmm.
So when you teach them to, learn a song also, or answer a question, if it's math, or the next words, writing a book, it's just all this continuous input that was all that we just are able to predict the next thing.
Okay.
And that was trained on all of this knowledge that's on the web. It just scraped the web and Wikipedia and websites, and based off of that, it trained a model to really just get really good at predicting whatever is online, and then you have this other intelligent machine. So these, I guess, three revolutions really brought us to the point of having a computer that has a lot of the same properties as the human brain and the human intelligence. So is there still something missing? Well, probably because you're interacting with ChatGPT and you could tell there's still something that it's lacking, whether it's just because it wasn't implemented as well as it could be. Um, it's possible, but if you ask it how many R's there are in strawberry, it will say 3 or 4, even after you
It'll say two.
two.
There,
Right.
there
Well,
are
there are three.
there are three. It'll
Sorry.
say two.
Good. Yes. So maybe I'm a maybe I'm a robot because I make a mistake.
Hmm.
There's something lacking that it doesn't learn when you're just predicting the next thing. You can't learn fundamental concepts like adding up two numbers. A kid who hasn't understood the fundamental concept, if you say what's 12 plus 20, he'll guess like, oh, that's got to be 30 or 40 something, because he's anticipating the next
Hmm.
what the answer should be, just based off of vague knowledge, which is also how ChatGPT, at least at first, worked, because it's just predicting things. And then they kind of patched that by having it run code for these. So it would know what it should do, write the code, and then the code would run, and then it would give you an exact answer. So it wouldn't make these mistakes.
Oh,
But,
okay.
but fundamentally, it still made the predictions in the same manner.
Hmm.
So, what else could be missing from that that human intelligence has that computers don't? Is it just this whimsical desire to do things that computers wouldn't? Because there's still going to be a difference between intelligent computers and humans. Computers probably don't have any desire pleasure when they hear music, when they do exercise or any like they obviously don't unless they're programmed to. So is that really all that's separating us, or is there something more that we haven't seen yet?
Okay. So, okay, I'll try my best to unpack everything that you just said, because there was, I think you're unaware of how many assumptions you actually make when you go through that logical sequence
Hmm.
and then you get to that quasi conclusion of like, is there anything else that ChatGPT is missing? Um, so for starters, I'll come from a totally different place for a second, totally totally flip the conversation on its head, and then maybe we can reach a sort of meeting point. And so, you had like, I think in a previous episode, just last episode, I think we talked about, or maybe it was earlier that we talked about like people in earlier societies. What did they do for entertainment? Well, they just sat around a fire and told stories or something like that. So if you had some guy, some kid is sitting there around a fire in some ancient civilization, and there's some wise elder telling some story about someone, some hero or some soldier or taking on a dragon or something. The kid is well aware, and everyone's well aware, that this hero in the story, he doesn't actually exist. He might have existed at some point, but he could not exist, right? It could be just a fictional story. And for the sake of the story, that story that's being told right now, we are imagining a thing that we are sort of like we're seeing ourselves in some fictional character in a story, and we're sort of imagining, we're taking on the point of view of some other character, and we're going through a story, we're going into a cave, there's a dragon. None of this is actually happening. Um, but it's all in our heads. It's for our enjoyment. It's we're going on a journey through the medium of some story. You with me so far?
Not quite. Are you because ChatGPT, deep reinforcement
Whoa,
learning
whoa!
are very concrete
I never
examples.
made it to ChatGPT. I'm just asking if you're with me so far.
So okay,
You don't know what point I'm making.
so how could I be with you?
I'm just asking you. I'm just asking that you are,
Have I listened to the words coming out of your mouth?
and that they're understood, and that you have no issue with them so
I
far.
I have no issue with any of the words you've said. I am familiar with all those words, not in that particular order necessarily, but they have been input.
Okay, they have been input, and then maybe around the same time in human civilization, I don't really know, maybe a little while later, there came the concept of a painting. Right, you could paint a human being, you could paint a portrait, you could paint some character on a canvas, and you show somebody, hey, kind of looks like a real person. It looks like you. It looks like, but everyone knows this isn't a real person. This is a representation. This is a painting of a person, right? We can imagine, we can project our own qualities onto this painting. We can compare. We can say like, ah, yes, I see the comparison. Yes, it's like me.
It's a simulation.
It's a representation, a simulation. I don't know if I would call that a simulation of painting, but it's obviously not. No one ever thought, oh, is the painting actually like me? No, everyone knew that it was just a way of representing me and you and all other human beings uh, in the painted form. It's completely in its intrinsic nature. It is as unlike a human being as a blank canvas that has no paint on it, or the shelf, or the wall. There's no difference between the painting of the human being in terms of its intrinsic nature, its intrinsic similarities to a human being, and a completely blank canvas or a wooden slab, a slab of wood. You with me so far? Is it, without getting to ChatGPT, is anything I said problematic?
No, you're saying that we've slowly progressed to create a more precise, accurate depiction, simulation of human intelligence or humans.
We have made more and more sophisticated contraptions, things,
That mimic, that imitate.
and because we are so interested in mimicking ourselves, because the attraction of the painting on the canvas, because I'm more interested in that than the blank canvas, because I'm attracted to things that mimic me, the concept of seeing me and other things is a fascinating concept to us human beings. We continue to make things to try to kind of make things in a way that like, oh, see how it kind of does what we do. Oh, see how like, oh, we can kind of like do, you know how like we do math? Well, you can do an abacus, and an abacus kind of like does the math for you. And you know how like we, reason through decisions, or you know how we like play games. Look, we can even make like a computer that does that. It's cool. It's like creating us. We are attracted to this process of kind of creating us and other things, even though what exactly changed? Why would we think that the grid of wires and an ALU and a thing and a bunch of chips? Why would we think that what changed between the canvas and the painting, and that like what exactly, why is that more intrinsically like the human being and the painting isn't?
Right. Okay. So for sure, we are obsessed with creating some sort of entity that mimics humans because for the longest time, up till now, and still, humans are the most intelligent thing that we know of.
Mm-hmm.
If there was a species of alien out there that was smarter than us, we would try to mimic them, probably, or create an entity that mimics them. And
Or first we would aspire to be like
aspire
them.
to be right.
Yeah.
So if you have people that look at other people who are smarter,
Mm-hmm.
they try to be like that because they want to get to that point of probably, having more control, more power, more efficiency, more all of these things are really to create not just something that, oh, look, we did it, we made a human. No, we want to go past that. We want to create something that's even more intelligent. We don't have a problem if it's, smarter than a human. But yeah, we create pictures of humans, but it's all simulation, maybe you could argue,
Mm-hmm.
at the end of the day, that we're taking these attributes that we observe in humans
Mm-hmm.
and trying to copy them, imitate them in
Right.
something else. And yes, this simulation has something to do with the medium that it's being done on, being processed on. So you could argue that we will never create something with a computer that's as intelligent as a human, or just not as intelligent, but isn't going to be equivalent to that of a human
Right.
because it's running on silicon. It's not running on carbon matter. And okay, maybe there are certain quantum effects that happen in your brain that don't happen, and certain like fundamental things but maybe those are negligible. Um, but
Wait, I want to can we argue that point out?
sure,
Because I think that there's a major disconnect here. Not only is it that the human is obviously made of different material. It's not only that, because obviously that could be, you have no idea. It could be a significant difference. It's that what the similarity that we have extracted there's no reason to think this is a meaningful similarity in terms of our intrinsic existence. This pattern of computation, right? We can sort of we can we can abstract away the concept of computation as Alan Turing did. We can look at an abacus and say that's a sort of computation. We can then look at a calculator, say that's a sort of computation. We can imagine a theoretical Turing machine that is not even real. There are no actual physical parts, and we can talk about the computations that it does, and we can talk about the computation that a human being does, and we can talk about the computation that a computer does. I completely fail to see the step where we suggest that this abstracted pattern that we have found across different things has anything to do with the intrinsic existence. It's like it's the same as if when a kid plays with dolls, they they identify patterns in how human beings behave. They identify, okay, what is a mom? What does a mom do? And then what does the pet do? And then what is like the neighbor who's kind of weird and I don't know loves has some weird hobby. What does that person do? And she sort of imagines all these different characters and she creates this scene of all these different characters doing these things.
Theory of mind.
Sure. And of course, we can see the similarity. We can look at the scene that she has created and we can say, hey, yeah, I totally see how the characters that you are kind of representing with these dolls and imagining this scene, I see how that could play out in the real world with real people. So I'm doing the same thing. I'm identifying a sort of it's as if the behavior that the child is representing in the scene, we'll call that the computation because that's the behavior that she has abstracted away and sort of put into these dolls, and it also exists in human beings. That has nothing to do with whether the dolls have an intrinsically equal existence to the human beings.
In your example, the girl uh, projected personalities onto these dolls,
Yeah,
but it just exists in her mind.
yeah.
She's made no. There's nothing coming from these dolls that
Well, there could,
show any.
in a sense, there are in a sense things that come from the dolls because the dolls are made in a human way, and I could even say that it doesn't only exist in her mind because she's able to display it to her parents or to her older brother, and they're able to get it as well. They're able to be like, "Oh yeah, I get what you're doing there. That's the mom, and that's the dog, and that's the car, and and I'm able to see the scene that you're doing, and they're able to imagine it playing out in real life because they're aware of these general patterns of human behavior that the child is picking up on and depicting in her dolls. So these things exist in a sense in the same way that computation exists because that's why I'm contending with your statement that it only exists in the girl's mind because the fact that a computer is computing and the fact that a human being is computing that doesn't only exist in our minds. Computation is a thing. So is nurturing, taking care of somebody. The way the child will make the mom in her play scene, she'll make her do the thing that moms might do, which is maybe take care of somebody. The dog might play around and roll over and like ask for food. Behaviors that exist in the real world, and she has kind of noticed that exists in, let's say, a pet or in someone who is dependent on other people.
So okay, so leaving aside the idea that if we all agree that these dolls are something,
Mm-hmm.
then what's the difference between us all agreeing on something with consensus and them actually being the thing? That's a different issue. Um, because I still think that what makes that case distinct from the computer exhibiting intelligence case
Okay.
is that the the computer is displaying these patterns. It's not just in the child's mind. So the computer is computing. It's not the doll is just sitting there and there's nothing coming from the doll. But again, I'm still not. I remember we had this debate a long time ago. We said, what happened if you take and this might touch upon consciousness a bit,
Mm-hmm.
but just focusing on intelligence for now.
Okay.
What happens if you map a human brain onto and you get all of the position of all the neurons at a given state and you model it on a computer, you have all the laws of physics and as rules, transition laws for this model, and you just let it run. which is basically what computation is at the end of the day, according to Turing. It's just you have a bunch of states, you have transition rules that take the state from one place to another, from one state to another, and then other and input and output. That's
Okay.
all. That's all computers are in an abstract idea.
Okay.
And I would argue that humans are similar. That all we do is we just exist at a certain state and time. We get input through our senses, and we output actions.
But do you accept that we have to make sure that you're not I forget what the term for the logical fallacy is, but it's when you assume the conclusion of your argument. Um, Meaning we have to accept that that is an assumption where that we don't actually know that we can talk about what is computation, and we can sort of come up with a definition for it and say that, well, it's when there's input and then there's some sort of transformation of something and then there's an output, and we can model our computers in such a way, we can think about computers and reason about computers in such a way, and we can even reason about the human being in such a way because we do know that human beings exhibit something like that. We do know that there are similar patterns of there's that we can reason about something called computation, and we do know that human beings do something like that. But to say that, oh well, that's because a computer is only that, and that's all it's made for, and there's nothing else that exists in there. To say that, well, that's all a human being is the same as saying that a human being is only the fact that the human being poops or the fact that the human being sleeps. Like you're taking one thing that the human being does and saying, well, this is really what it means to be a human being.
Right. Well, I base my argument off of the brain being the most important part of the human because we know that humans can survive without every other part of their body if it was, and unless it's your internal organs, but we agree that intelligence is not in the organs. Those are just features. They're not the actual essence of the human. It's all in the brain. We do have neurons that extend throughout our body and our spine.
Mm-hmm.
They're definitely very related. But at the end of the day, we know that it's the neurons that contain the entire experience of the human. Whether
I
or
don't
not,
know. I don't know if we know that. Are you sure that we know this? That neurons contain the experience of a human? I don't think we know where the experience is.
well, we know that if we chop out a whole bunch of neurons from a human,
Mm-hmm.
all of a sudden memories go. We know
Okay.
that when certain parts of the brain are afflicted with a disease, there are certain effect, like if your hippocampus is affected, they're the classics, the stories in psychology. A guy got his frontal lobe um, cut off, whether lobotomy or
Mm-hmm.
so. All of these experimentations lead, like, show a direct correlation with the result of severing certain parts of the brain. And we know that if you cut off an arm, you're still going to be basically the same person, just minus an arm,
Okay.
and probably grumpy about that.
Uh-huh.
But
But wait, you did say that there are neurons in the back and throughout something else. I think you said. But anyway,
yeah,
they're
that's fine. But
in
it's
the
just
spine.
neurons at the end of the day, and there have been scientific experiments that have been done with neurons to grow them and have these neurons compute or learn certain behaviors, whether it's reacting to light in a certain way so that it could. They built like a classifier
Mm-hmm.
to recognize dogs and cats just out of neurons on a petri dish.
Okay.
Um,
But still, we're conflating computation with neurons. I mean, just because neurons compute doesn't mean that neurons are equivalent to anything that computes. You know, right? Meaning it could be that in order to truly capture the existence of the human being, you not only need the computation, you need the neurons. In fact, maybe you don't need the computation. Maybe you can have human beings that really don't think that much, but there's still clearly a human experience there.
okay, well, again, the the idea of everything existing within the brain and neurons is based off of, well, not again because I didn't really say this, but there's nothing else that is part of the human except for what's in your body, unless you'd like to have a unless you'd like to argue against that. But everything.
No, for the sake of discussion, I'll allow
Okay.
it. I'll accept that point.
So then the onus is on you to say where else does it exist other than within the head, within the brain. Where else does this experience? Maybe I'm still not understanding your point of between computation and human experience. What is human experience then, if not just our ability to compute on a complex level? I mean, I'm not saying humans are just about adding two numbers, but give me an example of human experience that isn't just computation. You're saying a vegetable, someone lying in the hospital bed, unable to do anything because of severe brain damage or a coma. I don't know that there's much going on. I don't think that there's much computing going on other than the lungs breathing, the heart
Yeah,
beating.
no, I accept that. When I said earlier that there are human beings, okay, I was using computation in a different way than you are using it now, clearly. Um, I think you're, I mean, in the course of the last 5 minutes, I think, I have heard two quite different things, and really I think they contradict. I want to point them out. You have said that the human being is mainly the brain. How do we know this? Because the brain is where.
Hormones and hormones are secreted, neurons and signals from neurons are processed.
Okay, and why are those significant? More significant than the makings of the leg or the foot?
Because you could exist without your leg or foot. You could have those replaced by some mechanical part, and we'd still think that you're a human experiencing it.
Okay, nice. It seems to me that you are acknowledging human existence, that is to say, consciousness, as its own thing that can be identified, and the source of that is the human brain and not the foot. You can cut off your foot and you are still the same conscious being with the same sense of self, same memories, but if you change out the head, the brain, all this other stuff, or you get rid of it and you're just a body going down from the neck down, you will not be what exactly? You will not be there. You won't be. You won't have an existence because you'll just be gone. Is that fair?
Yeah, for the most part. I mean, I'm not completely dismissing the body. It still has
Yeah.
an important role,
Right.
but yeah, the majority of being human, intelligent, conscious in the brain, in the head.
Okay. So it seems to me that in the challenge that you gave me, you gave the answer to your challenge just before you gave the challenge. Because the answer to your challenge is in what you just acknowledged, what you just pointed out, which is this existence, this the state of being human that we are intrinsically aware of. There is no reason to believe that this exists, whether in the painting, whether in the abacus, whether in the calculator, or whether in the chat GPT. Literally none. And we can break down what a computer really is and what goes into it and why all the makings of a computer is our like when you really think about it, there's just no reason to see any similarity between a computer and the human being other than the output. Oh nice. We kind of like designed it in such a way that you can get an output that's like we kind of see how like it's kind of like what a human being does. But you can do that with so you can there's right you can have, let's say magic was real, you can have Harry Potter on stage and he can do some spell that, like, let's say actually makes a rabbit disappear, or you can have a magician go up there and he like does a sort of sleight of hand and misdirection, and he makes you think the rabbit disappeared, and we all say, "Ha! It's like the rabbit disappeared," but he didn't actually make the rabbit disappear. There's obviously a difference between what something really is and a sort of a behavior that they exhibit or an end result that they cause to come about.
Mhm. Okay. So I'm not asserting that any of the current technologies that we have um, r- can necessarily simulate a human, or we're not at that level yet.
It's
I
okay.
think
Point
I
out.
think it's right. I think we're getting there, but okay, your point is, how do we know at the end of the day, even if we do create a simulation that
Mhm.
is that seems to us as intelligent or conscious as a human, how do we know that that's really what's going on at the end of the day behind the scenes? It has the same. That is really
Not only how do we know it isn't. We know that it's not what's going on
well,
behind the scenes.
right. So that's where I disagree. Because yes, it's a problem. How do, like we said at the beginning, how do we know it's not just a big book with all the answers to the problem? You could simulate, you could mimic, imitate the human, and it won't really be acting as a human would. But I I think that based off of the fact that humans are made of matter and are basically states of existence that have transition states, the state of existence is what the matter you're composed of, including the neurons, the hormones, and you have input output, you have transition states, which are the laws of physics, and if you want to also include your environment, basically under that umbrella, what you have at the end of the day is a Turing machine. You have a computational machine that even if we're not, even if we're still missing a big piece of the puzzle, it is, it should be, and I can't see why not, why it wouldn't be theoretically possible to create something exactly like that. And before I was starting to give you the example of what happens if you upload a human brain
Yeah.
with all the laws of physics.
Okay.
In that case, I don't see what that would how that would be distinguished from a human, except it would probably say it's in immense pain because it's missing its body, because it knows that, but because it doesn't have any input or output, it would just be very confused.
So
let's say you put that simulation into a robot, so um, now it can interact with the environment. I don't see why that would be any different from your existence. Or similarly, taking it to the extreme, just literally duplicating you and creating a clone out of physical matter.
hmm.
I mean, it's both physical matter, but the same exact medium, that you would look at it and you would say, yeah, that's me. It's just been cloned. It's as intelligent. It's the same thing. He would think that he's intelligent. He would think that he's you.
But I wouldn't look at my clone and think that it actually is me. I would think it's a clone of me.
And he would look at you and think that it's a clone of him.
But that's
But
yeah.
what's okay, I think it's insignificant the fact that um, you have existed historically and he is the copy, let's say.
Okay. Let's say I say that's insignificant. I'm fine saying that's insignificant.
Because that's just a historical
Okay.
thing.
Okay.
Because I think that if you were to suddenly appear right there, a meter away from yourself,
Uh-huh.
that would be a continuation of your existence. I don't think,
Okay.
maybe you could argue that you literally died, but then then you're basically dying every fraction of time that passes because you're becoming something new.
Well, I think we have to be careful there. I mean, you can think of human existence as, in a sense, dying every.
You could, right.
But
But I'm
that's
saying,
not necessarily.
given that it's not true, then similarly, a clone of you would also not be you dying and becoming something else. There, you would be indistinguishable
Uh-huh.
from that clone.
I'm willing to grant
Okay.
that.
So then why wouldn't you be indistinguishable
Well, hold on.
from a computer robot that has your brain?
Sorry, I spoke too quickly. When you say indistinguishable, I actually think we are indistinguishable.
Okay. Why would you? What are you lacking that you're not equivalent to them, other than being a meter apart,
And
having
being
different,
and being two separate humans.
yeah,
That's
other than just very minute details. What is it that you have that your clone doesn't, that this computer doesn't? I think the onus is on you to.
I'm willing to grant that there's nothing that I have in terms of a qualitative existence that my clone doesn't have. I'm willing to accept it. Let's say I was cloned, and let's say that there is now another me here. In the same way that there are many similarities between you and me, and our qualitative existences are equal, I believe. Um, Obviously, I can't prove it, but we can talk about how you don't know for sure that other people are conscious. But I believe that you are conscious and that our qualitative existences are essentially the same. So yeah, there would be another me, and you would have really all my genes and all my memories, and from now that he's created, we would have slightly different experiences, maybe very different experiences, and yeah, I would have nothing in terms of my qualitative experience that he doesn't have. But I fail to see how that is the same as a computer, because in the case where I'm cloned, we're assuming that it's another human being who just happens to be also me.
Well, the idea of cloning in this case is just taking one molecule from
Mm-hmm.
you
Mm-hmm.
and placing it in a different area of
Yeah.
space.
Okay.
And in the case of a computer, it's taking a molecule of you
Mm-hmm.
and not using the physical molecule, but using a simulation of that molecule.
How do you not see that you have already you are now totally in a different case where you cannot assume that anything is the same now. You can point to similarities that exist between the two. You certainly cannot assume that it's the same
What,
in every aspect.
well, it's not the same in the aspect of matter, but everything that that molecule does there, if programmed perfectly, behaves the same as a molecule here.
Hold on, the molecule here, and then everything that this molecule does here. What does there exactly? Point to what's the molecule there? Where is it?
It doesn't, you can't point to it,
Okay.
or maybe you could if you're using, you change your computer to be one that uses molecules for its computation instead of electric uh,
Well, before we do
gates.
that, because that's changing the case, but because
But that's just a matter of the
well,
matter
you say
and the
that, but
fundamental material.
you're making a much stronger case than that. Because if you want to say that you have to have the same physical matter, and if you had the same physical matter, and you somehow could program it to be like a human, and it would all be the makings of a human, and you kind of just it's kind of like you artificially made a human in a lab, and then somehow, if we knew how to program the human brain, you did that, and it does the things that a human being. A lot of obviously, I would my response in many ways would be, well, we don't actually know that that's possible. We sort of imagine, okay, if one were to do this, then would it be the same as a human? In which case, I would say maybe we have a question there. But you're making a much stronger claim than that. You're making a claim that I think is far more audacious, which is that if I don't even have the material of a human, if I didn't even manage to somehow make a human in a lab and somehow program the human brain and make it the way I wanted to and have it the same DNA and make it a clone of Benjy or a clone of Cal, if I forewent all of that and I simply took the observable characteristics of a human being, took those and then simulated them in a computer program.
Not just characteristics, the fundamental building blocks of this human.
Hold on, but when you say the fundamental building blocks, so I create a computer program in which there are what exactly? Well, because the fundamental building blocks of the human being, and I don't even think we exactly know that, but let's just say it's DNA, it's amino acids, it's mitochondria, it's molecules, let's say, right?
Which are made up of atoms.
Okay, exactly made up of elements, carbon, etc., made up of atoms. All right.
Which behave in a very.
Hold on, you're jumping to behavior as if this is
no,
the
the
thing.
atoms behave.
Okay, but the atoms are the fundamental building blocks. The atoms of a human being.
We have the standard model of the universe, which predicts how atoms behave with probability, because at the end of the day, we're all probable. All atoms exist as a probability function.
Okay.
Or their electrons do, or the fundamental particles do.
Mm-hmm.
So at best, you could have a 99.999% approximation of the human.
Okay.
Because of that inherent randomness. But other than that, first of all, I don't think it's a significant thing. But first of all, I want to clarify something.
Okay.
Do you think that this simulation computer clone of you, is as intelligent as you?
We have definitely. So I mean, I don't, and that's
you don't. So that's even a stronger thing than argument than consciousness. That's even more audacious. Because it's literally a perfect simulation of you.
Well,
that any input you give it, it will give you an output that you yourself would have given. And therefore, I just don't see why, if you're intelligent, why that would be.
First of all, I don't accept that it is possible to make a simulation of me on a computer that truly would do everything that I do.
That's an audacious statement, because I'm saying, not right now, I'm saying Our models of
Gi-
reality are not perfect.
Given that we were talking about the future and we accept that we were talking about the future and we know that this is not possible now, it certainly is not too audacious to suggest that maybe this is not going to be, maybe no matter how hard we try, we're not going to discover that this is possible. Anything that is not in the next
What
5
would be an
years.
approximate, what would be a sufficient threshold for you to consider? 99% accurate, perfect replication of the universe of matter?
For me to say what?
That we can model the universe and matter within it. Like, let's say in 50 years, our computers are strong enough, have enough storage to model
Okay.
perfectly, not perfect, 99%.
But if we knew it was 99%, we'd be able to get to 100 because we would know what that last 1% was.
It could be randomness inherent in the system that
Okay.
can't be modeled perfectly.
Okay. If we
But
could
you'd be happy with
if we
them.
could truly reduce it down to randomness that couldn't be modeled.
Or like we predict the weather, we have our weather every time you build a model,
Mhm.
there's some resolution that it has. And the faster you want to run, the higher the lower the resolution has to be. And so
Okay.
we're willing to take this trade-off to model the weather. But to model a human brain, to model an atom, okay, we know how it works. We know how atoms work. Do you accept that?
Okay. Let's say
How atoms interact with most states of matter.
I don't accept it based on my scientific knowledge. I accept it for the sake of the discussion. But I also believe
Okay.
that you know that we know.
Yeah. But we know how when you emit certain electromagnetic radiation at different wavelengths, what's going to happen to the energy state of that atom, of the electrons in that atom, whether the charge of that atom, what will happen. And if you want to simulate 10 atoms, you could do that.
Okay.
Humans, a neuron is probably made of
Hold on. Stick with
millions.
the atom for a second. You simulate the atom on a computer. What does that mean exactly?
All of the interactions with the environment
Uh-huh.
surrounding atoms.
Yeah. But where is the atom?
The atom is simulated on other atoms.
Okay. Which means that the atom that you are simulating is not anywhere other than where it actually is. The other atoms that are simulating the atom that you're simulating, it's a simulation. We look at it and we can imagine, we can see the similarity between what it's doing and what the atom is doing. But the actual atom is only where it is. It's not actually there. You following me?
Yes, I see that it's not the same exact atom, but it behaves exactly, this collection of atoms behaves exactly like that single atom.
This collection of atoms, what is this
Together.
collection of atoms?
That's the circuitry on the computer.
The circuitry on the computer. But I don't think it's the circuitry on the computer that you're referring to. What do you mean? Wait, what? So, because that's not, you know, if you just show someone if you open up the computer and show someone the circuitry, they'll be like, okay, but what does the program do? Right? They'll be like, I don't know what that means. So when you show them a program, a simulation of an atom, it's smoke and mirrors, Benjy. It's a show. It's like a magician on stage doing a bunch of things to give the audience the sensation that the rabbit disappeared. It's all for the sake of creating an experience in the audience's head. So too, when someone creates a computer program, it's all for the sake of creating some. It could be for creating an experience in the viewer's head, in the case of like a game and a video or something, or it's to do some functional task that is useful to human beings in the real world. We always make computer programs to service other human beings. There's
Well, I mean, the point of why we create computers, I'm not sure exactly that could be extrapolated forever, but
yeah, no, I accept that. But you see what I was saying? You see that it's the same as the
not
magician
really,
making the rabbit disappear.
because the magician is a weaker case of the actual magic that is expected. What do we expect when the rabbit disappears? We expect its atoms to literally disappear from existence,
no longer be anywhere.
and the information to travel in space and reassemble the atoms in a different place, right? That you would consider magic, right?
Okay.
If you destroyed the atoms of the rabbit at this location in space, turned it into information, sent it over there, reassembled the rabbit.
Okay.
Okay? That would be the actual magic. What the magician does he doesn't have that ability.
Yeah.
So he simulates it in a weaker manner
Yeah.
because he doesn't actually, he has a different rabbit over there or something.
Yeah.
Or he has two rabbits.
Yeah.
Okay?
You don't think the simulation of the atom on the computer is a weaker?
No, because presumably to get such a resolution, you would need, to get a resolution matching that of reality, you would need equal or more amounts of atoms to simulate it.
Okay.
In the case where, let's say, we're using 5 atoms to simulate 1 atom, we're using more atoms, a stronger, exa- a stronger amount of
So when we
of
have,
matter.
I see. So when we have a computer running a computer program that simulates an atom, think of the huge number of atoms that are in that computer, running that computer program. That's far more than one atom.
Well, I'm comparing it to the magician with the rabbit. It's not
Yes.
smoke and mirrors because that's a weaker case. He's not. If if you were expecting, I don't know, a magician to turn water into red water, and then he literally turns it into um, gold, actual gold,
Uh-huh.
then you would say that's okay. That's magic. That's even more magical than what I was expecting.
Okay.
So the point is just that you have even more you're not lacking anything when you're simulating. You don't lose anything when you simulate um, 1 atom on more atoms.
Okay. Okay. I have to go.
What would happen to you
Hold
if
on.
I
Hold on.
replaced every atom in you with twice as many atoms? Okay, but I reduced the effect of those 2 atoms so that they only have the same effect as half of half of each one.
I don't know. I don't know what the ramifications of that would be.
You would be the same thing. You would be the same person. You would be the same. You wouldn't have be smoke and mirrors, Cal. You would be Cal. Except you just happen to have an abstract. You happen to have more atoms in you than you think you originally did. But that's just an abstract concept. It's just the materials you happen to be made of. But at the end of the day, it's just neurons flying about in the brain and the complexity arriving at that. And I appreciate your argument by laughter, but I fail to see how it logically refutes my
I
argument.
don't claim that my laughter logically refutes your arguments. Simply a small tangent. The laughter was. Um, so yes, but when you have me here and you simply replace my atoms, which I'm not convinced necessarily that I would be the exact same person. I don't know, or maybe that there's some entity of me that was not replaced. There's some aspect of me that was not replaced that is metaphysical. But that's
Your atoms are replaced every 10 years. You don't have the same atoms,
right. But I think that
probabilistically.
that very scientific fact points to the idea, or points to, is at least evidence of the idea that we are not only our atoms.
You heard it here, folks. We are not only our atoms.
I don't see how that's controversial at all. I realize that there are many people who are convinced that only physical matter exists, and you can't even consider that there's something metaphysical. But for the sake of this discussion, I'm willing to only stay in a physical realm because I think I can still win, even if, with a physicalist worldview assumed.
Well, there's no winning or losing.
No, of
We
course,
both win.
of course, we both win.
And we both lose.
I think I can win with you, even if we assume
rather than winning at me.
right. Assume a physicalist worldview. Okay, so assuming a physicalist worldview, then okay, so you replace all my atoms. I'm still a human being. I'm still sitting here. Blah blah blah. It's so different than the computer. I still don't understand the simulation of an atom because we have to get to the what is the atom, right? When you say the simulation of the atom is the same thing as the atom, it's not the same thing in the sense that it's exactly the same thing, but intrinsically in terms of its quality as a thing, as an entity, in its qualitative existence, it is the same. But what is it? Where is it? The atom is a physical thing, especially if we're assuming a physicalist worldview. Are you listening, Benjy?
Yes.
Okay.
I was looking up maybe some other arguments people have for why a simulation, what are the fundamental differences between a simulation and an actual entity other than our frame of reference.
It's such a it's so what do you mean? Of course, it's I don't, let's say you have who's a comedian you really like?
Robin Williams.
Robin Williams. Robin Williams, a very animated comedian, really got into his acts, whether it was his tone of voice, his facial expressions, his impressions that he would do, his different voices he would do. It wasn't just the words he said, right? It wasn't just the script, to the extent that he had a script. He might have been improvising. But it wasn't just the words he said, it was also his delivery, it was everything that he put into the act, right?
His life as well, his
Hold on.
character as a person.
His character's personality. I'm talking about the act, the specifically the act. I'm aware that Robin Williams as a person is more than outside, more than just who he was as a comedian. But his act on stage, that's what I'm focusing on right now.
Okay.
Okay. So you could have boring Ted from The Office, and you could give him the words that Robin Williams said.
From How I Met Your
Mother. Nice. So you could have Kevin. Kevin's a good example. Or Stanley. You could have Stanley from The Office, and you could give him the words that Robin Williams said in a particular act that had the audience boring. And you could have Stanley get up there, and you could just recite the words that Robin Williams said. And he would in some way be simulating the Robin Williams act, right? He would be kind of recreating it in a certain sense of the word.
Right.
But it wouldn't all have the same effect. It wouldn't all be the same thing, and it wouldn't all have the same reaction from the audience.
Well, if he dresses up as Robin Williams.
I knew you were going to say that.
If he puts on the same, voice as Robin Williams, then first of all, the effect on the audience will be identical. And just like intelligence, you'll also be able to see intelligence from this simulation, because just whatever you input, intelligence is just how input to a person is processed, and then the resulting output is.
I would argue that even if you had Stanley, first of all, I had a very valid point that I was making with Stanley only reciting the words, which I think got a little ignored, which is fine. But even if you had Stanley recreate every aspect of Robin Williams' performance down to the bodily behavior, the voices, the thing, even if you had all of that happen, it would not have the same reaction from the audience. You want to know why?
Does the audience know that it's not?
Yes. Because what do you mean? It's not Robin Williams. It's Stanley.
Okay. But that's why the frame of reference is important, because there's something more existing. Everyone knows that Robin Williams has a life outside of just his act, and so it's not him. But if Stanley takes on, literally just kills Robin Williams, buries him, gets plastic surgery to look like him, masters his personal routine, and memorizes the people in his life and and relationships and how to interact with them.
I see. So
no one will notice.
Okay. So because it's hypothetical. So the thing is, it's relevant. The point.
If people saw this process happening behind the stage, then yes, they wouldn't think it's Robin Williams because they see that it's not happening behind the stage. But because at the end of the day, there still is a difference. The atoms the atoms are different. They've suddenly broken, and his Robin Williams' continuous stream of existence has ceased to exist.
Okay.
And someone is just started to exist that is mimicking.
Okay. Yeah. And once people are aware of that, it'll have not the same effects. But as long as people are not aware of that, it can have the same effect.
Right. So first of all, that's why I come back to intelligence, because you still, I think, say that it won't be as intelligent.
So the reason I said that, I knew there was something we wanted to get back to, and I couldn't remember what it was. Thank you.
No problem. The thing you were wrong about, yes.
The reason I said that was because I was thinking of saying first that we have to discuss again what intelligence means in order to properly answer the question, because I was initially going to answer it in a more rigorous, analytical way to give you a well-defined answer. But then I decided, to hell with that.
Didn't we define what intelligence was and how it's, like classical intelligence?
Okay, if we define intelligence to be simply reducible to
efficiency,
reducible to behavior memory. that a system can exhibit, then within the domain that the simulated me exists in that computer program, it is as intelligent as I am in my domain. Now, these two things are still different because we are in different domains.
What's your domain?
The world that I live in.
What's its domain?
The fake world that it lives in. The
Okay.
fake world that it doesn't even live in. It can't even talk about it as if it's a thing.
Okay, but we're assuming in that case of it being a robot that it has cameras that act as your eyes, it has microphones that act as your ears,
No,
it has all the
it
sensory.
doesn't have cameras that act as my eyes. It has a computer. Not sorry, I shouldn't use the word computer in that context. It has a programmed behavior that simulates vision. It's very different.
What is vision?
Benjy,
It's very important. How
I
do
know
you
what
think that the eye works?
I know what you're getting at.
The eye
But you
has
said,
photoreceptors.
Benjy, you said that the reason your head, your brain, is more important than your foot is because the human experience is more attributable to your brain than it is to the foot.
The processing part of it, yes, and most of the human experience, yes.
But the reason the processing is meaningful is because it is correlated, at least, with the human experience.
Explain.
What I'm explaining is that on one hand, in one breath, you are using the human experience to make the point that the human brain is the most important part of the human. And therefore, if you were to simulate the human brain, you would be simulating the human. And in the next breath, you are suggesting that the human experience doesn't even exist. So as long as you simulated the human brain on a thing that cannot possibly have the human experience, you are essentially making the same thing as a human.
Let's define human experience, because I think that's...
Here we go.
We've
arrived.
That seems to be the main issue here. What is the human experience? What is consciousness?
Actually, I know. So I realize we've arrived, but I want to continue to dance around it a little longer because I do accept it is something that is hard to explain, quite hard to explain. It's much easier to explain it by kind of like hinting at it. But I hint at it to other human beings who I have full faith understand what I mean when I hint at it, so that they can identify it in themselves and identify what I'm talking about. And that is more effective, especially when we're talking about consciousness, than trying to come up with an objective description of
it. It sounds to me like a biased way. A loaded way of approaching the subject when we should be approaching with cold, calculated indifference. But I just want to clarify where you stand.
Okay.
If I created an exact clone of the same matter as you said that would be intelligent.
Yes.
That would have human experience.
I believe so. I'm willing to grant it for the sake of the discussion.
Okay. And if we created a robot whose computation happens on silicon instead of in neurons, atoms, it wouldn't be, it would be intelligent, I think we said, in the classical sense.
Classical meaning that intelligence is simply defined by behaviors that are exhibited. Output.
Okay. What is the other sense that it doesn't have?
The other sense is that it's more of an internal quality.
You can run, but you can't hide, Cal. Define, explain what you mean.
I felt that it was sufficient simply to provide some way of understanding what another sense would be without fully explaining. Because it's an internal quality.
It's different because we know it's different, and it's something that we can't see.
It's different because it's internal. I explain why it's different. You can have some. For example, here I'll do better. So we can imagine someone who's very intelligent, but that intelligence never really becomes noticed by the public. Like we know of very intelligent people who did very meaningful things and breakthroughs in science and whatever. We had Stephen Hawking, Albert Einstein.
Do you mean potential?
Well, hold on. And we would accept that those people are intelligent, and we can point to what they accomplished as evidence of their intelligence. But we can we know in fact that they're
assertion.
But we know once I say
we can probably say that there are people that would have accomplished the same things if they were born at a different time.
Exactly. And we can also just imagine somebody who is extremely intelligent, but maybe has other characteristics that hold him back. Maybe has circumstances that hold him back. Maybe is just extremely, extremely lazy. There are a lot of very lazy, intelligent people. And there's plenty of people who look at him and have no concept that they are as intelligent as Albert Einstein.
Okay, so you're saying you in that case, you versus your simulated robot entity,
Mm-hmm.
you have that internal quality of intelligence.
Yes.
The robot doesn't.
Yes, absolutely.
Why? What do you mean? If that robot was replaced you at a young age and you were put in a box, then that robot would not be able to accomplish everything that you've accomplished in your life?
But I thought we were talking about the internal sense of intelligence, in which is independent of what you accomplish in your life.
Okay, so I'm just trying to understand what you mean. That
I accept.
there's a latent potential that you have that robot doesn't.
Well, it's not potential. It's we in the case of the human. In the case of the human, we can separate the internal quality of being intelligent from the exhibited output that points to that intelligence, that lets other people know that intelligence is there. With a robot, we can't. The output is the same as the intelligence. The robot is intelligent not because of its output, but its output is its intelligence.
If I were to put you in a box, no one would know whether you're intelligent or not.
Okay.
It's only when you're out of the box that I'm able to pose questions to you and figure out that you're intelligent or not.
Okay.
If I took the robot and I put it in a box,
Yes.
or if I turned it off,
Yes.
no one would know whether it's intelligent or not.
Okay.
But if I were to turn it on and then ask questions of it, I'd be able to find out that it's intelligent. So just because you're not running the program, the robot maybe, as much as you're running you, doesn't mean that it doesn't also have that internal intelligence.
You're right. Even in the case of the robot, the output is not the same as the intelligence. It's the fact that it is capable. It is because if someone were to develop the new version of ChatGPT, even before anyone saw it, it would still be intelligent, even if nobody knew it. Well, if I accept this use of the word intelligence, but let's say I do. Okay, let's move on.
Let's move on. Okay. But what we could probably, so intelligence, whatever, maybe there's some very subtle distinction you can make between the robot. I wouldn't, but you would. But
Oh, right. You were asking me.
we're talking about experience,
Yeah.
life experience. You're saying the robot does not possess this. You do. And here is more, okay, the more
Hold on.
controversial.
Hold on. Before we get to that, are you going to go to the next step? Because I thought right before it was the clone, that was the clone of me,
Yeah.
with my DNA, human atoms, carbon, whatever. I accepted that it is like me. It has an internal experience. It is intelligent, at least for the sake of the discussion.
And leaving aside maybe a soul.
Yeah, leaving aside.
We're not talking about soul.
We're not talking about a soul. We're assuming a physicalist worldview.
What's the next step? Because we already disagreed with the robot simulation.
So, well,
Right.
the robot that's sitting there in this world,
Yes.
it's made of silicon and circuitry and the makings of a computer. It exhibits the same behavior as I do. You're asking me, is it as intelligent as I am? In a certain sense of the word, yes.
Yeah, we've established that.
Okay. Isn't there another step where then you give me a computer program that's where there's a simulation of the world that I made, and then there's me. There's some like image on the screen that is like, that's me, and it does what I do in the world.
What do you mean? What's the difference?
Isn't that the next step after the robot?
Say again.
The next step after the robot is
Yeah.
if you give me this computer screen.
Yeah.
And you click start.
Yeah, and it's a picture of you.
And it's not just a picture of me, but there's a representation of me on the screen, and he's sitting in what looks like this apartment, and he's talking to you, what looks like you, and I can have it play out, and it'll do all the things. It'll go to my office, my work, and it'll call up my mom before Shabbat, before the Sabbath day, and it'll do all the things that I do, and it's all so detailed, and it's also really all
highest resolution. Okay.
Yeah, all of the information.
So you're saying the next step is that previously the robot interacted with our environment,
Yes.
In this next step, the environment is itself is simulated. It's a simulated
Okay. Yes. Isn't this what we were talking
copy
about
of
when
the
we were talking
environment.
about simulating an atom on a computer?
Yeah. Okay.
Okay. So then, is this character on the screen? Does he has intelligence? I am.
Yeah.
You're asking that question to me.
Well, I know that if you disagree that the robot,
Hold on. I agreed with the
okay,
robot.
so fine.
You pushed me to agreement
Well, you still were kind of confusing about the intelligence part, but fine.
because it depends what we mean by
This,
intelligence.
fine. Let's
But
say the environment is this perfectly simulated, perfect resolution environment copy of our environment.
yeah,
And that stimulation of you is interacting with that environment. Is it intelligent?
yeah, not at all. Definitely not, because here you can't even point to anything that's me. That's what I was trying to get at with the atom, simulating the atom. You can't point to anything that actually is like me in this simulation. You can point to kind of like the whole world that's modeled in this computer program, and then you can point to the representation of me that goes through the steps that I would do. But that obviously is not.
So you need the location, you need it to be localized in a separate server on the. You're saying we just simulate the entire world, you included, but and then you're saying, oh, but wait, it's all part of one simulation. Uh, what's it called? Simulation drive, whatever. Simulation program.
Okay.
Engine. Sorry.
Okay.
It's all one simulation engine. There's no distinction in the engine between the molecules composed of you and that those composed of everything else in the environment.
Mm,
And so you're saying it's
nice.
all.
There you go. Well,
That's what you mean?
yeah, that's what I
Okay.
was trying to get several things. That's at least one of the things. Yes.
Okay. So that seems, I don't know. To me, that's your basic argument. Maybe there's more. You'll have to explain. I would start by saying the atoms that you're made of
Mhm.
came from the environment. They came from all the pizza you ate, from the pizza your parents ate, from the dirt that grew, that came from the stars that exploded. It's all the same atoms
Mhm.
compose you. So there is this, um, there's this continuousness of you and
Continuity.
continuity in reality in the universe.
Indeed.
And
Very, very mystical.
right,
Very spiritual.
you are the universe looking back at itself, and you are the mind of the universe. So am I, though.
I think we at least have to accept that. All right, fine. I'll let you continue because
But
I don't want to get too off too.
okay, so what else is it other than you need some distinction of where the processing hardware for the simulation of you is from the simulation of the rest of the universe in this physics engine.
Yeah. See, even if so, you say that I am made up of atoms that come from elsewhere in the environment, and I am the pizza that I am, etc. But even so, one of the things that you point to is that we're not just the atoms, because of course you can recreate me on the computer. We are my behavior, and my behavior is encoded in the kind of programming that's inside me, and that is me, or at least in this discussion, we're accepting that. That is, at least I can say, it is specific to me. It's not in the wall. It's not in that suitcase. The encoding, the programming, right? The qualia. I don't even know what that word means, to be honest.
So what you said, I don't know what it
You don't know
means.
what that means?
Qualia?
Yeah.
Hopefully our listeners know what it
Yeah,
means.
I'm sure somebody out there knows what I just said. So all of that is in me, even if the atoms that make it up came from the pizza, let's say, or came from elsewhere in the environment. Whereas with the guy on the computer screen, who is a representation of me, first of all, there's obviously a distinction between the front end representation of the character and the back end processing of the character, which doesn't exist with me in the real world. Um, and then also the processing that because what we really care about is the processing. We don't care about the pixels right on the screen. The processing that does me, it's not unique to me. You can't really point to any processing, anything going on, any computation that's occurring that's unique to me. It's a different entity that's doing the computation both for me and for you and for all these other characters that are in this world. Whereas with me, all my computation is specific to me, yo.
Well, one thing that is interesting is when you create a physics engine or any simulation,
Hmm.
um, let's say with cellular automata,
Okay.
you have this idea of simultaneous updates, where you could either you kind of redraw the entire grid at once.
Okay.
So every cell or atom in the environment, it has its updated state calculated based off of the surrounding states
Yeah.
at the previous state.
Okay.
Um, so you could, and then basically it stores a copy of the previous state and then creates your new state and then completely wipes out the previous state.
Okay.
As opposed to, so that's how we usually do it. Um, but as opposed to more of like a chain of updates, because, is every state in the universe right now, is it, is there one single state? No, obviously. It's not like there is a state and then the entire universe is wiped out and then a new state exists, right?
Well, you could think of it that way.
You could model it that way,
Yeah.
but change is probably it's more continuous than that. And like atomic behavior, take this with a grain of salt because I don't know the true answer to this, but I would assume that things happening at the smallest scale of time at femtoseconds, there's some atomic quality to time, I think,
Okay.
but in a way that is all relative still. Like it's not simultaneous everywhere. Things will happen for an atom here at a different rate, that like the update to that system will happen at some atomic uh, level
Hmm.
that happen at a slightly different state. Whatever. Maybe it's kind of irrelevant, but the point is just that how we how would we model this? Like, would it work like a regular physics engine where the entire universe is wiped clean and the next, or is there some sort of? It's more about the proximity of everything. So your atoms, your existence as a human, is not really affected by anything that happens far away, right? Your state.
Okay.
Like it's only when atoms really interact with each other. That's why quantum physics does play a part, because the current understanding of our universe is that atoms interact with everything everywhere
All at
all the time,
once.
all at
She
once.
said all at once, man.
Is that the book?
It's might have been a book first, but it's a movie. It came out a couple years ago. Won an Oscar.
Mhm. So so there's like that interpretation, but for the sake of leaving aside that small amount, like really an atom doing something in the Andromeda galaxy has no effect on you, 99.99999% of you
Okay. Let's say.
and your behavior.
Yeah.
So it's only what's in your bubble that has an effect on you. That's all that we have to simulate. So when we're doing the simulation, right, you're saying, oh, there's nothing that really points to me that's separate from the rest of the universe. Well, it depends how we're calculating the update function of you in that environment, but presumably we would be saying every atom interacts with atoms that are close to you, and then updating your state accordingly, just like how it is in real life, in reality.
But it's still so obviously not the same. Even if, first of all, what you just described sounds like it sounds like an implementation detail to me. And once you're suggesting that the how well this properly simulates uh, our world is dependent on these implementation details, as soon as you say that, it's all out the window
Well, no, I'm
because
saying that it's an implementation detail that's insignificant, and that how it's actually implemented should give you an insight as to how similar it is to reality, how equivalent it is to reality, because
it's okay.
you you are composed of a bunch of states of atoms. Can we agree on that?
Well,
Assuming
when you
that,
say can we agree on that, I'm willing to accept that for the sake of the discussion.
okay, your atoms, and maybe we're going in circles on this.
That's why we should get to just consciousness. We should get
We should just do it.
we should just go. We arrived some like 30 minutes ago, and now let's go for it.
Okay. And it's similar to human experience
Right. Because
or
that's what
animal experience. For I think we should extend it also animals, maybe.
yeah, let's say.
Okay.
I think there's a different level of conscious experience that animals have, and if you showed me a dog, I'd be like, sure, certainly seems conscious. Maybe not at the same exact level that I am, but certainly there's a conscious experience there. Whereas if you showed me like a worm, I'd be like, maybe on some level there's a conscious experience, but something very unlike.
Right. So that, if we get to where I stand on consciousness,
Mm-hmm.
it's exactly what you're describing, but you're not obviously going to accept.
Mm-hmm.
But it's just a matter of scale, of how conscious the thing is.
Uh-huh.
An earthworm has something less so.
Mm-hmm.
A tree, even less.
Mm-hmm.
And then when you think about it, what it really comes down to is just complexity arising out of processing
Okay.
input and output.
So let me ask you a question.
And yeah,
Is the city of New York City conscious?
in a way,
What do you mean in a way? Are you conscious in a way?
that you can't ask it, is it conscious?
Uh,
But yes, it consciousness existing as like a stream of complexity that arises due to um, a processing system underlying it. Yes, it has some
okay.
level of consciousness.
Okay. Can I ask you another question?
I feel like there's a gotcha coming,
Well, maybe. I
but
mean,
go for
I thought that one was gotcha, but you answered. I mean, you're at least consistent with yourself.
it.
um, are there an infinite number of conscious beings in the universe, or a finite number?
Well, if we're going to stay consistent,
Mm-hmm.
as I would like to do,
Mm-hmm.
the way I described it was that basically everything that interacts with anything else has some level of consciousness, which at the end of the day is everything, because everything interacts with everything. Otherwise,
Mm-hmm.
if it doesn't interact with anything, then there's no difference between it and not existing.
Mm-hmm.
So, what we think is consciousness, we usually ascribe to humans, animals, anything less, we don't really bother with in the same way as calling it conscious. But I guess if you want to say there's an infinite amount of consciousness in the world, by definition, there would be, but it would be kind of like a nonsensical thing to say because not nonsensical, but like pointless because it doesn't really have any ramifications because we don't, a stone interacts with the world. It has that minute level of consciousness, but there's no point in really considering it conscious because relative to a human, it's nothing.
Mm-hmm.
Relative to a living being.
Okay. Um, what I was trying to get at there was that there are infinite. Well, I guess.
There aren't an infinite
Yeah, I've only,
amount of permutations of molecules and fundamental particles, assuming the universe is not infinite.
yeah.
So technically, it would just be a very large number.
It's. I think if you accept that New York City is conscious as its own entity, although maybe you don't even delineate
Which
consciousness.
some poets have also, just to put that out there, like poets and writers, journalists, they describe it as the beating heart of the city,
Yeah,
the living
called
organism that
it's
is New
called
York, a
personification.
metaphor and not actual reality. Yeah, okay.
Well,
Okay, sorry.
that's a point against you. Are you suggesting
No,
that that's a point against me?
I was being facetious,
Okay.
saying what you're saying.
Okay. Um,
Self-deprecate.
okay. If you accept that New York City is conscious, then yeah, I guess maybe it's not infinite because at the end of the day, if the universe is finite, can you produce an infinite number of combinations of things
Right.
from a finite? I guess not. But it's like
Sure.
it's crazy, right?
Crazy. That's a personification.
It's out of this universe. The number of
No, it's very much in this
possible
universe.
combinations of things you could make because then like you're conscious according to our definition, right? According to at least the way you're thinking about it, you're conscious because you are a sophisticated, intelligent system, right? But then I could say, well, you as well as the bookshelf, you now form a system that I'm going to then consider and look at and be like the Benjy and bookshelf together.
You could do
You
that.
could think of a system like you could think of it as a system, and I could say, okay, now the Benjy bookshelf conscious being is its own conscious being, and it must have
Mhm.
is it then a separate consciousness that the Benjy bookshelf has that's separate from your consciousness, or is it just
Well, it mostly is. It's 99.999%
the same?
my conscious,
Uh-huh.
and that little tiny amount of input output interaction that the bookshelf provides.
Okay.
But if you took one atom from my brain, I would still have a stream of consciousness
Hmm.
that, for all intents and purposes, is my conscious. You know,
Okay.
even if
And
you took.
the bookshelf has the stream. Well, I guess I can't say the bookshelf because it's too simple. It's not as sophisticated as you. But if we considered like the system of bookshelves in the world, if we considered even the distribution of bookshelves and the manufacturing of bookshelves, we considered all the moving parts that went into bookshelves, and we considered all of this as its
If
own
you created
system.
a Turing complete, meaning if you created a system of bookshelves to act with all the basics needed to create a Turing machine
I don't need that
of
because
ends
I don't need that because
and
you accept
gates.
that dogs are conscious and dolphins and even earthworms.
Okay.
So I don't need the system of bookshelves.
Okay, I was just saying it's theoretically possible. Okay, you brought up the system of bookshelves. Do dogs and animals have consciousness? I think so.
Yeah, I think so too.
Okay. Some recognize themselves in a mirror, some don't.
Does the system of bookshelves recognize?
Well, I would say like the animals that don't recognize themselves but still have consciousness.
Okay.
If
Can this?
you created a system of bookshelves that are complex enough to recognize themselves in the mirror,
What does
because
that even mean?
it means creating a simulation of
Because it,
using bookshelves as your
because as long
fundamental
as you
logic
create a
gates.
simulation, that's the same as the actual thing. If anyone's confused, like we might be confusing our listeners, our many millions of listeners. We might be,
I don't know if we're confusing them because I think we've gone over the same point a million
I think
times.
we might be confusing them because I think we have to explain what we're talking about. We're talking about consciousness in two very different ways, which to me is for you to say that my way doesn't exist, and that's what I'm really contending with you about.
Well, it's not a personal attack.
No, it's not. No, it's not because it's personal. It's not because it's personal. It's not because it's my way. But the for me, there's the input and output that you described. There's the behavior of a system, right? There is even the complexity of a system, and none of this has to do really any. You could say there's that it does have something to do with consciousness in the sense that there might be causative relationships there, certainly at least correlative, but at least in terms of their intrinsic quality and looking at them as what they are, there is such a thing as consciousness that it is independent of those. I want to do a small exercise. I want
Sit-ups.
I want you to imagine a red juicy apple in your head. Are you imagining the red juicy apple?
I refuse.
I
I
think just by me saying it, I think some image of a red juicy apple. Maybe it's like on a
sure.
on a plate on a table. Maybe there's a nice fireplace
Mhm.
crackling. Maybe it's snowing outside.
My neurons
Let's
are firing
let's even make it let's even
in the
make it better.
same
It's like a
pattern.
smoking cup of apple cider. All right, that's what I want you to imagine. Okay.
So the same neurons that fire when I've
See, but
actually had an apple, like this morning,
but
a
you're
juicy apple, the
you
same neurons are now firing now
okay.
and giving my brain, or not the same neurons, but many overlapping neurons are firing,
Okay.
inducing the same sensations
Okay.
within my brain. I'm starting to salivate.
Yes.
Um,
And I could also describe the Super Bowl as a bunch of people wrestling over a ball. I could use that sentence. I could say it's a bunch of guys wearing pads wrestling over a pigskin, and that's what the Super Bowl is. And
yes.
somebody would be like, yeah, I guess you could kind of describe it that way, but there's a lot in it that you're not really capturing, right?
Right.
Like Taylor Swift, for example.
Integral part of the Super Bowl.
Yeah, there's a lot in it that you're not capturing. And the same thing is going on here. You could describe the human experience of drinking a cup of apple cider by a fireplace with snowflakes falling outside. You could describe it all as neurons and synapses firing.
Mm-hmm.
You can describe it that way if you want. In a way, it's reducible to that.
You could also open up a brain and spark with some electricity,
Uh-huh.
as we've said. in previous episodes
Okay.
and induce that same experience so that the person himself thinks that he's experiencing it.
But none of this undermines my point, because all I'm trying to do is point to what human experience is and show that we have no reason to believe that this exists in a simulation. We can simulate it because we know how to simulate the exhibited behavior, the outward behavior, but the human experience of feeling that hot cider, the taste of that cider, the setting with the fireplace, the sound of the fireplace, the snow falling outside. There's no reason to think that sensation is occurring in any simulation anywhere. And here's what I was really trying to get at. And here's my proof that there's something going on here. And you can't discount this as being nothing. You can't simply reduce it, deconstruct it to, oh, it's the outward behavior, this is what's happening, and if you were to simulate that in a computer program, it'd be the exact same thing. Here's the proof. Where's the cider? Right? You're imagining a cup of apple cider. When you have the cup of apple cider in front of you and you actually drink it, you can say, oh, the synapses are firing and there's a cup of apple cider, blah, 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 and the atoms go in and blah, blah, blah. Okay. But if I were to imagine the cup of apple cider, I'm imagining it in my head, and I'm not even concerned with the synapses, right? I'm concerned with the image of the cider. It's not just the image of the cider, it's the mug, it's the steam coming out of the top of it, it's the surface that it's resting on. I'm imagining that image in my head. There is an image in my head right now that I am imagining, that I am seeing. Not with the same clarity that I'm seeing you, but I am seeing it. Okay? And we're empirical people, right? We're assuming a physicalist worldview. Right? When we observe things, we say, hey, what's going on there? That's something. But where is it? Where is the cider? I'm seeing it, but where is it?
Where is it when you imagine it in your brain?
Yes.
And we're saying we're not allowed to say that it exists in the synapses.
Well, it obviously doesn't exist in the synapses. You could say that the synapses are what's causing it. You could say that it's directly attributable to the synapses. You could say that if you didn't have the synapses, it wouldn't be happening. You could say all of that. You could say all that. But we know that if we open up the brain, we would not find the mug of apple cider. We wouldn't. We might find the synapses, but we wouldn't find the mug of apple cider.
Where is the mind's eye?
Where is the mug of apple cider?
That's a mug.
I think I said it's a mug a little bit ago.
Maybe.
I was describing other parts of the image.
We'll go back and
we'll play it back. Play it back.
Well,
do you get my question? I don't want you to misunderstand my question. Do you get my question? You open up the brain, you can say it's the synapses. Fine, it's the synapses. But show me the mug. You can't do it.
It's a hallucination.
Okay, very well. It's a hallucination. It doesn't matter. Because it's fine. Because when you say it's a hallucination, it's in contrast to what is in the physical world, right? What is outside of my mind. That's fine. That's fine. I don't care about that because I'm trying to just show that consciousness is a thing. And when we go back all the way to trying to show that consciousness is a thing, I don't have to be dependent on the physical world. That is, on the world outside of my mind, because what I'm imagining in my mind, it's true that it's not happening outside of my mind, but it is happening in a certain sense, and there's no reason to think it's happening for some simulation on a computer program.
Not only does the apple cider in that case, right?
Yeah.
Exists not in the physical reality.
Okay.
Because you're imagining it.
Okay.
Even in the case that you're trying to make a distinction with, where it is actually in front of you.
Okay.
It's not actually there.
What do you mean?
I mean, when you smell that apple cider, when you look at that apple cider, you're just seeing electromagnetic radiation reflect off of the apple cider.
I understand.
Onto your eyeballs.
I understand.
You're never even touching the apple cider because it's just electromagnetism, the sensation on your fingers.
But
if you cut out your eyeballs, if you're a blind person,
yes,
it's the same apple cider all of a sudden. It just exists in your mind's eye. Okay, so that's the first point.
It's not a point though. It doesn't. Okay, but continue.
It is a point.
Well, it doesn't get
because
it doesn't address my point.
I think it refines it, first of all.
Okay.
Because we don't even have to make a distinction between physical reality and your existence.
Okay.
Everything in your mind is your simulation of it in your mind. It's reality is just your simulation And a hallucination is just a distinct uh, a distinct way of seeing things in a simulation because it's simulated in your brain, but it's not simulated in your senses. But at the end of the day, it's just all in your brain. So where is the apple cider? That's still what we're coming back to.
Yeah.
And you still say it's not allowed to be in the synapses.
No. You can show that the only. You can even show me that the only reason I can imagine the apple cider is because of the synapse. But that doesn't mean it's in the synapse. Because if you look at the synapses, you won't see the apple cider.
You're saying, how does an external person see the apple cider in your brain?
Yes, actually, I am saying that because that is still in line with my point. Because if the point is that there's no, it seems that your point is that there is no real internal experience. The internal experience is itself an illusion, which, by the way, it doesn't make sense.
Not that there's no internal experience. I'm saying there's no apple cider in your brain.
No, I accept.
It's just a pattern.
I accept.
And someone else looking in your brain
but
would look at patterns.
I'm trying to point us to the internal experience I'm using the apple cider as a representative. The apple cider is a proxy in this mental exercise because what happens when you try to point to consciousness is you kind of do this thing where you're like, oh, what does it really mean? It's just this. It's just the synapses. It's just me doing things. You create a character on a computer screen that sips apple cider, so to speak, in the computer program and goes to work. And how is that thing different from? And I'd be like, well, I'm conscious. And you'd be like, well, what is that? It's the apple cider. I'm imagining apple cider. Does the character on the screen imagine apple cider?
If you tell him to imagine apple cider, he'll imagine apple cider.
No.
Because the same patterns.
What does that even mean?
It means the same thing as it means for you, which is transmit to the areas of your brain to simulate, but to what's it called when you reconstruct the experience that you had, the more real experience that you had of interacting with an apple cider. So when you give that instruction to that simulation of you on the computer, it too, because it's a perfect replica of your brain, it will also, in the same way, you have your input that stimulates some neurons that will stimulate those other neurons that induce that pattern that is similar
the language you're using
to that when seeing the apple cider.
The language you're using makes zero sense if we're talking about a computer program. Let's say I'm a developer, right? And you're like, I want you to simulate the world. And I'm like, all right, so I got, we got people, I got Benjy here, I got Cal here. These are just, two people, I got tons of people, all this detail. And then the product manager comes to me and he says, okay, now we have a new feature request. Make Cal imagine apple cider at midnight on March 9th. And the developer's like, okay, you want him to say I'm imagining apple cider? Do you want him to talk about his experience with apple cider? It's like, no. He doesn't do anything. He doesn't actually say anything. No one actually sees that he's doing anything imagining apple cider. I just want you to have him imagine. What does that mean?
It means alter the neurons in his brain at that time to induce the same pattern as it was when experiencing apple cider. Similarly, if I were to do that to you, it would be via shooting some invisible electromagnetic radiation that affects the neurons in your brain that turn on the same time.
Okay.
That when you are imagining apple cider.
Okay, so let's say tomorrow I go to the product manager, I say, all right, I finished, it's done. He imagines apple cider. The product manager's like, great. How can I see it? And I'm like, all right, here it is, and it's me.
And if you're able to see the state of his brain at that moment,
you can't see the state of his brain. You just see him.
What do you mean? You have it's a perfect simulation. You could rewind it and say, all right, here, let's print out
the state of his brain,
the location of all the neurotransmitters.
All right, fine.
And he'll probably be talking, and he'll be like, what? Apple cider. And then he'll continue talking. Nope. He won't know. Things don't just randomly pop in your brain, and then you're like, why was I thinking about that?
You're getting off track. We're getting off track. We're a team.
This whole thing has been off track.
No, this has been the best. We're over 2 hours. We're gonna keep going. Wait, so let's say I grant that there's an actual like brain model. It's truly a full simulation, and it's like, okay, look at the brain waves at my brain model of Cal. Look at that. He's the thing, the neurons. He's imagining episode. And the product manager's like, well done, and we ship it, and it's great. Where's the apple? Where? In the computer program. You have.
It's in your brain. Everything in your existence
but when you
is
showed
in
me-
your brain.
when you showed me the brain
am
model-
just in your brain.
But
I don't. There's nothing.
you really exist. I believe that. But you're showing me the brain model where he.
But to you, you know I exist in some external sense.
Okay.
But all I am to you is some part in your brain
But you're
made of
ignoring
neurons. I'm just a pattern in your brain.
the problem with your sentence is the word all. It's like suggesting that when I play in the NBA championship on 2K20, whatever they're at now, I used to play 2K2, I think, back when I was a kid. I play it on the video game. It's like saying that is the same as when somebody actually trains all their life and gets up there in front of thousands of people and has to like put his career on the line and put under pressure and take the game-winning shot. It's like saying that Stanley getting up and reading Robin Williams' script is the same as Robin Williams actually performing his act. The problem is the word all.
Because there exists something external to it that you can point to.
It's not just that there exists something external. It's that even if we are just focused on me or just focused on you, there is something more than that because I think therefore I am, Descartes said. Descartes said. Thank you, Benjy. There's clearly something more. We're at the point where I can't explain it any more than I've already explained it. When I imagine apple cider.
Imagine. Yes.
Yes, but that's the point. That's fine. I think, therefore I am. Thinking is still Descartes' point was that even when you think, you're right. When we talk about this world, your thoughts are not the same as things that actually happen in reality. But the fact that you are thinking is also evidence of something. In other words, and in what he was saying, I think, therefore I am, you think, therefore you must exist in some way. Even if you say that all this is simulation, you still exist in some form. Even if it's the fact that you are hooked up to some simulation, where then you are then seeing this whole world. But still, you exist. You think, therefore you are.
Kyle, I'm just a figment of your imagination. You're just doing a podcast with yourself and filling it all in afterwards.
Plot twist.
You're just very good at switching your voice.
So when I imagine the apple cider, I use the word imagine with the full understanding that the apple cider doesn't exist in the real world, but it still proves my point because it proves that consciousness, it shows what consciousness is. It proves that consciousness is not the same as the real world. In fact, it proves my point. Your response. Your response. Imagine. You're only imagining it. Yes, I'm imagining it, and that proves my point because it doesn't really exist in the real world, and yet I can see it in my head.
And so too could a simulation, if you were to, for some reason, program it to imagine things in addition to actually interacting with the real world.
I did it.
Maybe it would be.
Benjy, I did it. I literally just programmed in the 2 minutes that we were talking about.
So you did it, and you demonstrated how completely useless it is. But
not only is it completely useless, it's preposterous because I didn't do anything. Because it's the same. The computer character on a computer program imagining an apple cider is the exact same thing as no developer doing diddly squat because there's nothing actually happening in the computer program.
No, things are happening. It's the neurons in the brain are firing.
There's no brain.
It's a simulation.
It's a simulation, exactly. It's for us. It's for our experience of it to say, hey, look at that. It's very interesting. You simulated the human brain on the computer. But if we actually ask ourselves, what's going on? The simulation
would say, I just thought of an apple cider.
No. Well, even if it said that, it would still just be saying that. It wouldn't actually be... It wouldn't actually
Sure it would, because there's literally no difference
there is the world of difference.
And the simulation
there is a world
doing
of difference.
it.
We have to bring up the Chinese translation room.
It's time?
It's time to bring up the Chinese translation room.
For those that don't know, the Chinese translation room.
Yes. Please.
is a thought experiment where there exists someone locked in a room
Mhm.
with a compendium, a dictionary, a reference book,
Mhm.
encyclopedia, written in Chinese and English.
Mhm.
And every question posed under the door in a piece of paper is in Chinese.
Mhm.
And the person in the room takes the question. He doesn't even know it's a question or something. He knows that he's supposed to output something.
Mhm.
He gets input, he knows he's supposed to output. That's the one thing he knows. And he looks in his reference book, looks it up, gets the corresponding, um, maybe it's just all in Chinese. It's just all Chinese. There's no English.
Oh
It's
yeah,
just Chinese
that makes more
input, Chinese
sense.
output.
Yeah.
And he does not speak Mandarin.
Right. He just
Mandarin,
he
there's
just
no language.
he just has a reference book to tell him the appropriate
Yeah.
response in Chinese to a given line in Chinese.
And then he just serves it up, whatever the output was.
Exactly.
So, I don't think it's so completely different from everything we were saying before.
Okay.
But the point of the thought experiment is that the person in the room has no understanding of what he's doing.
Yes.
And he's behaving in an intelligent way, but he doesn't actually understand it.
Right.
I would say that is like the neurons in the brain that do not understand. That is like the complexity that arises on a whole is in Chinese, but the fundamental particles and pieces themselves that constitute the whole
Ugh.
do not have in any meaningful way an understanding of what they're doing, except for the fact that when given input, they have to do output.
Okay. But if the person was behind the door and he didn't have a reference book and instead he was fluent in Chinese, would that be a different situation?
And in that case, you're saying he understands what he's doing,
Yes.
but he's just taking in input and giving output.
Yeah, he's doing the exact same thing as the other guy was doing. He's taking an input, giving an output. From an outsider's perspective, there was no difference.
You're right. It would be like
But
a
is
neuron for some reason having an understanding of the entire brain and each neuron uh, understanding everything.
okay,
In
and
which
wouldn't
case,
that be different than if the neuron didn't have that understanding?
would it wouldn't be different in terms of the final behavior,
Well, what does
and
that
it would
mean?
make no difference to anything.
What does that mean though? There would be something different going on, wouldn't it? If
Oh,
I
I don't know. You tell me. I thought the in this case of the Chinese person, sorry, yes, who understands Mandarin,
Mhm.
is he giving better answers?
No, he's giving the same answers.
Identical answers. So
Identical
then there's
answers.
no difference.
There's no difference. If you're behind a door and you have a reference book and you speak to somebody in Chinese without any understanding of what you're doing, but you're just using the reference book to give appropriate responses, that is the same thing as when you actually understand Chinese and are fluent in Chinese and doing the same thing.
The the conclusion is the same. It's the same as your neurons actually understanding what the whole of the brain does, but still only deciding to behave like neurons. It's like the difference would be like if humans all lined up to behave like neurons and pass messages to each other like neurons, and then create this super intelligent New York City. Um,
Can't you think of humans as exactly that, and of New York City as a system containing all those neurons?
in a way, I wouldn't say New York is it's just different than an individual human, but I mean that would be like an analogous case where like the humans sort of have an understanding of everything,
Mm-hmm.
but they still don't have the same, complete understanding of New York City and won't be able to behave like New York. Like you'll have certain complexity arising from lots of humans working together that is not possible by a single human. But maybe I should ask what you're driving at and if I'm falling into a gotcha.
To me, the gotcha has occurred multiple times in this conversation. I don't understand. I don't understand what you're saying. If a person doesn't know Chinese, it's the same as if he knew Chinese. There's no difference.
But you said that the answers are going to be the same.
Yeah, the answers are going to be the same, but there's a world of difference between the two.
Why? He's following the same. What
No
difference is he
difference, Harry.
making?
It made all the difference in the world. You saved an innocent man from a terrible fate.
Should have let Sirius Black get eaten by
You helped
Hassan.
uncover the truth.
What was the point? He died in the next book.
but
No, 2 books
but that's
later.
like saying, what's the point of being born? You're gonna die in 90 years.
Exactly. Suicide pact right now.
I think we have. I've done my best.
Mhm. I think it's a good point.
You've done your best.
We've all done our best.
We've done our best.
All of us. I know you don't like the word all.
Well, I didn't like it in that one time. All right, this was our longest episode, over 2 hours.
Mhm.
Great. It was a great conversation. We got nowhere, but at the same time,
We got everywhere.
we got everywhere. we really, I think we really made a lot of progress. All right, so long.
This has been the Benjy Podcast.